Hey guys, and welcome to AP problem number 11. This one asks you to answer the following questions using principles of chemical bonding and molecular structure. Question A says, consider the carbon dioxide molecule CO2 and the carbonate ion CO3 2 minus, and draw a complete Lewis structure electron dot structure for each species, and account for the fact that the carbon-oxygen bond in CO3 is greater than the carbon-oxygen bond in CO2. So, as we come to part A, part I of this, we see the CO2, or carbon dioxide, has a linear structure with two oxygen bonds on each side of it with double bonds and two lone pairs on each of the oxygen. This is because the oxygen want to be far enough away so they'd be 180 degrees, forming a linear structure. For the CO3, the carbonate ion, we see since there's three oxygen, two of them get single bonds and have three lone pairs, and the other oxygen forms a double bond with two lone pairs. Because of this, the molecule has resonance, so that double bond can move throughout the molecule. So it could be end up going here or end up going here in different structures. And since it's also an ion, we have to put it inside brackets and name the charge. Part 2 says account for the fact that the bond lengths are different. So if we looked in CO2, both the bonds there are double bonds. Therefore, there's more energy in the bonds, which makes greater energy, and the bond lengths are shorter than CO3, which has single bonds, which have less energy than a double bond and make it farther. Also, since the CO3 has resonance, the double bond with the double bond, the electron can move throughout the molecule. This would also change distance throughout. Part B says consider the molecule CF4SF4 and draw a Lewis structure for both of those. And then in terms of molecular geometry, account for the fact that CF4 molecule is nonpolar, whereas SF4 is polar. And I forgot to say that the molecular geometry for the carbonate ion would be triangular pyramidal, I believe, because there's no lone pairs off the center atom and there's three bonds. Because we're talking about molecular geometry too, double bonds only count for one. Same with triple bonds, they only count for one bond. So if we look down at part B here, part I of part question B, we see the CF4. There are 4 fluorines around the center carbon ion, not ion, just atom, and every single fluorine has 3 lone pairs. And then as the SF4, it is the same, but since S is on the third row, because we count the hydrogen and helium as one row, it is the third row down. It has an empty d orbital, so it can hold more electrons. It is exception to the octet rule, so it also has a lone pair off of it. It's pretty much the same as the carbon one, but with a lone pair off the center atom. This causes this to be tetrahedral bipyramidal because of the lone pair, while this one is just tetrahedral. And when you do a tetrahedral, the 3D structure is different from this because it'll have them not be 90 degrees apart, but since it's 3D, it can use another axis, and it would be about 106.5 degrees apart, whereas on 2D, it only looks to be 90. And with the lone pair in the S, because of the d orbital, it changes the structure up and would become tetrahedral bipyramidal. Also, because of the lone pair, it gives a certain amount of attraction on where the lone pair is. This makes the SF4 polar. Well, since CF4 doesn't have that lone pair, it's pretty much just balanced throughout the molecule. That means it's not polar, where SF4 is polar because of that lone pair. That sums it up for AP problem number 11. Thanks for watching.